This is the second part of 2021 Vssc Electronics Technician question paper solution. The first part we have solved 40 questions. So in this part we will solve the remaining 40 questions. Also, if you like the video, please hit the like button and share with your friends. Let's move to the next question. Question number 41. Which logic gate is a parity checker? The XOR gate is used as a parity checker. This parity checking is used to detect error. Parity bit, we will send a parity bit with the data. This is used to detect error. Let's move to the next question. A hemisphere has a total surface area of 300 pi mm square. What is its diameter? So hemisphere, see, if you cut a lemon like this, we will get a hemisphere. So this curved area, the area of this curved surface is 2 pi r square. And this circular area, it is pi r square. So total area, he has given here total surface area. So total area equal to pi r square plus 2 pi r square. That is equal to 3 pi r square. Now substitute the values. So 3 pi r square equals 300 pi. So pi will cancel it. If you divide left side and right side by 3, what you get? 1 r square equals 100. So what is the value of r? If you take the square root of 100, we will get the value of r, which is equal to 10. What we need? We need the diameter. Diameter is equal to 2 times the radius, 2r. So 2 multiplied by 10, it is 20 mm. So the answer is option C. Next question. A surface mount chip resistor designated 0805 has the size of. Now 0805 means 0.08 inch, 0.05 inch. That's what it means. Length and the width. Now we have to relate it with mil. Now I hope you know 1 inch equals 1000 mil. 1 inch equal to 1000 mil. So 0.08 inch equals what? X mil. So let's try to, if you cross multiply, x equal to 0.08 multiplied by 1000. So what do you get? You will get 80 mil. 80 mil. Similarly, if you want to 0.05 inch, if you want to convert to mil, you have to multiply by 1000. So 0.05 inch equals 0.05 multiplied by 1000. What do you get? You get 50. Right? So the answer is option A is the right answer. 80 mil by 50 mil. So you should know 1 inch equals 1000 mil. Question number 44. For checking the working of a transistor using multimeter in diode mode, an NPN transistor can be regarded as. How do we check a transistor? We'll check for the diode action. So our transistor is, this is NPN. So this is N region, P region. P region is the base. Then one more N region. So this can be said as N, P, N. So if you see this, then this combination of two diodes, cathodes are connected together. Let's see what is the option. Two diodes connected in series with anode of first one is connected to the cathode of no. Two cathodes are connected together. Option B, two diodes connected in series with cathodes of both are connected together. No, anodes are connected together. Correct. So the answer is option C. Two diodes connected in series with anodes of both are connected together. That is what tells this diagram. Next question. Question number 45. Which of the following indicate noise margin in a digital circuit? Let's consider the TTL logic. The TTL logic, up to 5 volt this logic can go. Now there is a TTL output low VL. The output, when TTL output is low, the maximum value it can go is 0.4 volt. Output low max. But if we take the input, we input low max, that is 0.8 volt. So if I look at this here, VIL minus VOL gives 0.4 volt is the difference. So remember that 0.4 volt is the noise margin. In the TTL, 0.4 volt is the noise margin. So if you take the high, here in the question they are given the high output V. So here we have a 2 volt. That is the V input high. So minimum input, for a high input, minimum value of voltage is going to be 2 volt. This should be provided by the output, that is 2.4 volt. That is the V output high min. So this is the noise margin of 0.4 volt for the TTL. In another video I will explain you in a good way. So the answer is V output. We here see, if we here VOH, V output high minus V output high min. Okay, so minimum output high minus V input high minimum. This is the noise margin, that is option D. If a car travels at 40 km for 3 hours and at 60 km per hour for remaining 2 hours, what is the average speed of the car? Most of us, what we will do, we will add these numbers and take the average. That is wrong. Okay, average speed is given by average speed is the total distance upon total time. That is what the equation of average speed. Now What is the total distance? See here, this first 40 kilometer hour, 3 hours. 3 hours we have traveled at 40 kilometer per hour. And after that, he has traveled 60 kilometers. 60 kilometer per hour for 2 hours. So total time is, what is the total time? 5 hours. No doubt about it. But what is the total distance? Three hours he has traveled 40 kilometer per hour. So distance is what? Distance equal to speed multiplied by time. So 40 multiplied by 3, you get how much? 120 kilometer. He has traveled 120 kilometer. First 3 hours. Similarly, in the second 2 hours, he has also traveled 120 kilometers. So total distance equal to 120 plus 120. So it comes to 240. 240 divided by 5. 240 divided by 5 comes to 48 kilometer per hour. So that is the average speed. So the answer is option B, 48 kilometer per hour. Question number 47. How many selection bits are required for a multiplexer with 16 inputs? So multiplexer means what? Many to one. Many to one. That is what the multiplexer. That means one output will be there. We are having 16 inputs. So first input, second input. So like that, we have up to 16 inputs are there. So this is a 16:1 mux. So how many bit? If you have 4 bit selection line, then we can select out of this 16, we can select any of the inputs. So let this be S1, S2, S3, S4. So 2 to the power 4 will give how many combinations? It will give 16 combinations. So we need 4 select lines. Answer is option B. Question number 48. What is the logic function Y implemented in the given switch circuit assuming switch is open condition as logic 0? Now see, this is what gate. If switches are connected in series, what gate? It is AND gate. If switches are connected in parallel, it's a OR gate. So now let's write it. Here B and C are AND function, which is ORed with D because D is parallel. These all are in series with the switch. So these all are in an AND function. So the answer is A, which is answer A, B, C, D. So answer is option C, A, B, C, D. This is the answer. Approximate wavelength of visible light is. This question was there in many question paper. It is 380 nanometer to 750 nanometer. 750 nanometer, which light it is? It is red because wavelength is more. 380 is near to 380. What it is? It is violet because wavelength is less for violet. An ideal transformer has 220 turns in the primary and 11 turns in the secondary windings. 220 milliamps current was flowing in the primary winding. When secondary winding was loaded, what is the load current in the secondary? So we can write the equation, turns ratio equation, N upon N2 equals E1 upon E2 equal to, current is reverse, okay, I2 upon I1. Now here what we have to find? 220 turns in primary. So N1 is equal to 220 divided by N2 is there, 11 turns. Current, primary current he has given. What is the primary current? Secondary current he has not given. We have to find primary current. What is the primary current? 220 milliamps. Now we can divide 220 by 11. So that what we get? It's 2 times. So it comes 20 equal to I2 upon 220 milliamps. Right. Now how do you solve it? Cross multiply it. So I2 equals 20 multiplied by 220 milliamps. If you multiply 22 into 2, 44 multiplied by 2 zeros. Instead of milliamps, what you can write? 10 to the power minus 3. If you see 10 to the power minus 3, how we can write? 4400, 1 upon 1000. 2 zeros cancels. So what we get? We will get 44 upon 10. That is equal to 4.4 amps. So clearly the answer is option D. 4.4 amps. Question number 51. In BCD, decimal number 15 is written as 15. We have to write 15 in BCD. BCD means what? Binary coded decimal. Binary coded decimal. So we'll write using this, we'll mention 0 to 9. So 0 to 9, each digit with 4 bits we have to, each decimal digit with 4 bits we have to represent. So 1 we can write it as 0, 0, 1. Now next is 5. 5 is 0, 1, 0, 1. Correct? 1, 2, 4, 5. So this is the option. So option C is the right answer. Option C. Question number 52. The common emitter DC current gain of a bipolar junction transistor is 99. What is its common base current gain? So beta equal to what he has given us? 99. We have to find alpha. What is the equation for alpha? Alpha should come always low value. So beta upon beta plus 1. What is the value of beta he has given here? It is 99. 99 beta plus 1, 99 plus 1, that is 100. So it is equal to 0.99 is the answer. So answer is option B is the right answer. What is the bandwidth required for amplitude modulated system using carrier frequency 1.5 MHz and modulating signal frequency 20 kHz? So how the this one AM frequency spectrum looks? This will be the center frequency, a center amplitude we can say Vc, and we'll have two side bands. Okay, this two side band is given as Fc plus Fm and Fc minus Fm. So now what is the bandwidth? How do you bandwidth? Bandwidth equal to Fc plus Fm minus of Fc minus Fm. So it becomes minus Fc plus Fm. I have one step I have skipped. Okay, that is why it is like this. So FC cancels. So bandwidth FM bandwidth equal to 2 times the message signal. 2 times the message signal. So it is, what is the message signal? 20 kilohertz. So the answer is option B, 40 kilohertz. So 40 kilohertz is the answer. The charge developed across a capacitor is measured. What is the unit of capacitance? That's farad charge. What is the unit? How we measure the charge in coulombs? So the answer is option C. I like to finish this video in this video itself. These all questions. So please with me. Let us finish it. Which bipolar transistor configuration provides maximum power gain? The common emitter configuration provides the maximum power gain. Question number 56. Two inductors of value 400 millihenry and 225 millihenry are placed parallel on a common core. If the mutual inductance is 90 millihenry, the coefficient of coupling is. Coefficient of coupling is given by what? Mutual inductance upon square root of inductance, two inductance L1, L2. So if I write here K equal to, what is the mutual inductance? 90 millihenry. What is the value of square root of L1? L1 is 400 multiplied by, what is L2? L2 equal to 225, right? 225 square root. If we simplify this, what do we get? 90 upon square root of 400 equal to 20. Square root of 225 equal to 15. So now 15 and 90 we can cancel. 6 by 20 we will get. Again 6 by 20. What we got? We got 6 by 20. So how do you simplify? We can write 6 by 3 by 10. Right? It equal to 0.3. So 0.3 is the answer. Coefficient of coupling. So you should know what is the equation for coefficient of coupling. Let's move to the next question. Which of the following is not a unit of electrical energy? Answer is option C. kV is not the unit of electrical energy. What is 1 electron volt? 1 electron volt equal to 1.6 into 10 to the power minus 19 joules. That is what 1 electron volt. The perimeter of a rectangular garden is 72 meter. If its length is 4 meter more than its width, what is its area? So we have a garden. Perimeter means what? Sum of all area. So perimeter here, this is length and this is a length and width. Its length is 4 meter more than its width. So length equal to 4 meter plus the width. Now what is the total perimeter of the perimeter of the garden? The perimeter of a rectangular garden is 72 meter. If its length is 4 meter more than its width, what is its area? Area here, area equal to what? Length into width. Okay. Now the perimeter means perimeter equals sum of all this length, sum of all this length. So we have 2L here, 2L plus 2W, 2 width. We can represent as A also, AB also we can mention. I mentioned as L and length and width. And one more thing, to say perimeter he has given us 72, right? 2 times. Then width is length is telling it is 4 plus W, width plus 2W. Now this is the equation for the perimeter. So just we will open it up, 8 plus 2W plus 2W. So 72 equals 8 plus 4W. So that means which gives 64 equal to 4W. Now width we have to find. Once we find the width, we can find the area. Right. So width equal to what? Width equal to 64 upon 4. Right. It is 16. So we got the width. Once we get the width, what is that? Width is equal, what is length? L equal to 4 plus width, 16. So it comes to 20. Now we know the length and width. So area equals 20 multiplied by 16. So it is 320 meters square. So the answer is option A, 320 meters square. Question number 59. EST wrist strap resistance shall be of the order of. In ISRO, all the soldering and testing table has got EST wristband connection, and finally it is terminated. It is connected with a 1 mega ohm resistor. What is the material used for energy generation by nuclear fission? That is uranium. These radioactive materials are used like uranium, thorium, polonium. Those are radioactive materials. It is required to increase the maximum range of a radar by a factor of 2. The peak transmitter power has to be increased by a factor of. For a radar, R max, the range equation R max is given as PT GT, that is the transmitted power, transmitter gain, sigma target area, effective area of the antenna, receiver antenna, upon 4 pi whole square. And the minimum range is max means received signal is minimum. Yes, mean to the power 1 by 4. This is the range equation of the radar. You should know this equation, otherwise you can't solve this question. Range of the radar. You should know this. Next, let me solve it. Now, the question is only related to the power, transmitted power. So how I write it? R max equals PT, let it be PT to the power 1 by 4 I will write. Then remaining all terms, GT, sigma, that is the target area, effective receiver area, upon 4 pi whole square, S min, minimum signal received. This all what I will do, I will consider it as a constant. To the power 1 by 4 is there. So now my R max, radar range max, equal to PT to the power 1 by 4. This terms all I will take it as a constant to the power 1 by 4. Again the same thing, how do I write? Transmitted power to the power 1 by 4. One constant simply I will write, because 1 by 4 if I take also, I will get a constant only. So we are worried with the variation of the radar range, maximum range, and the transmitted power. Now we have to increase the transmitted power by a factor of 2. So now See now what is from the options. First I will put a value 4. R max equal to K, let it be there. Now I'll put 4 1 by 4 because I am assuming that transmitter power has to be increased by a factor of 4. Whether it is correct or not, I will just check it. So K, let it be like that only. KR we are not worried about. Now how can write this? I can write it as half into half. That means first we will take the square root of 4. What is that? 2. Again if you take the square root of 2, what will get? We will get 1.41. So this is not the right option. Now again what I will do, I will take 16 R max. 16 times power PT equal to 16 I am taking, and instead of 1 by 4 I will write it as 1 by 2 1 by 2. So 2 times I will take the square root. So K square root of 16 equal to 4. So again I will take the square root. So I will get 2K. So K we are not worried. So now the range has doubled. Range has doubled. So the answer is option D is the right answer. Number of valence electrons in a boron atom. Answer is option D 3. This aluminium, gallium, indium, boron, all of these are third group elements. A 16x2 LCD module typically has 16 by 2 means in a LCD display there are 16 characters. 16 characters on the top line and 16 characters on the bottom line. To send this data, usually we use 8 data lines. Using 4 data lines also we can transmit the data, but it is usually in the standard is 8 data lines. What is the operating temperature range of military grade components? So it should work in our Kashmir and all. Kashmir also, Rajasthan also should work. So the range is from minus 55 degrees Celsius to 125 degrees Celsius. So it's 0 degrees to 75 degrees the commercial grade. Commercial grade. Commercial grade. Find the area of the sector of angle 30 degree cut from a circle with a radius of 4 centimeter. We have a circle with 4 centimeter. This is a 4 centimeter radius and 30 degree we made a sector. What is the area of this sector? So area of sector equals, what is the area of a circle? Pi r square. This is multiplied by theta upon 360. Theta is the whatever angle you are making the sector. So pi r square, I'll put the values. Pi multiplied by 4 square centimeter, no 4 square multiplied by what is the theta you are made the sector? 30 degree. 30 degree upon 360 degree. So this comes to 1's 12. So what we get? We'll get one second. Okay, now we got it. Now what is get? Pi multiplied by 16 upon 12. So 3 times, 4 times. So 4 pi upon 3. What it comes? 4 pi upon 3. 4 pi upon 3 equals 4 pi It comes to 4.18 centimeters square. So the answer is option D. Option D is the right answer. We'll get 4.19 centimeters square. So the equation you should know. What equation you should know? Area of the sector equation you should know. Which of the following circuits convert sine wave to a square wave of the same frequency? It is the Schmitt trigger. Schmitt trigger. Schmitt trigger, we can give a sine wave input. I'm just drawing it. I hope it is correct. We can give a sine wave input, and the output you will get a same frequency square wave. Okay, it is square wave. Don't think anything else. It's square wave or a square wave or rectangular wave, depending upon. I hope it is a square wave only should get. Square wave frequency, because the same frequency is maintained. Sine wave is having a particular frequency. So same related to that, we have to get the square wave output. And this stable multi-vibrator also, we will get a continuous waveform. Whether it is rectangular or, and bistable multi-vibrator was got two states. Question number 67. In a bridge rectifier driven from the power source Vm sin 100 pi t, the peak inverse voltage for the diode is. In a full wave rectifier, the peak inverse voltage of the diode is as the maximum voltage of the source. Whatever that is, it is Vm is the peak value of the voltage. So Vm here, what he has mentioned, Vm sin 100 pi t. See, this you can compare with general equation Vm sin 2 pi ft. So Vm is the peak value. So the answer also, option B is the answer. What is the frequency here? What is the frequency? It is the 100 Hertz. 2 pi ft. 50 Hertz. It's a 2 pi ft, no? Here, if it is 50 Hertz, when you multiply, we will get 100 pi t. Question number 68. When fed with an input voltage of 15 volt and current of 0.1 amp, the DC regulator delivers 1 watt output to a load. Its efficiency. What is efficiency equal to? Output P output, no, power output P output upon P input. What is P output? P output is all, he's telling 1 watt. What is the P input? V into I, 15 multiplied by 0.1 multiplied by 100, then only efficiency will get it in percentage, 100. So this is equal to 1 upon 1.5 multiplied by 100. So what do we get? We will get 66. That means 67% is the answer. 67% we will get. So the answer is option D is the right answer. 69. The following circuit, the switch is moved from position 1 to position 2 at time t equal to 0. And the capacitor is initially uncharged. Which of the following statement is true regarding the voltage across the capacitor as a specific instant t? The question is about the charging of the capacitor. Now, when the switch is at the position 2, how the circuit looks? How the circuit? The circuit is simplify as like this. One 10 volt source is connected and there's a 220 kilo ohm resistor, 10 microfarad capacitor also there. Now what is the time constant? That is tau equal to RC. What is it? How much? 220 into kilo ohm 10 to the power 3 multiplied by 10 microfarad 10 to the power minus 6. I'll write it here up. So we can write it as 22 multiplied by 10 to the power 5 into 10 to the power minus 6. This how can I write it? If I write 2.2, then I can write 10 to the power 6 multiplied by 10 to the power minus 6. So these two cancels. It is 2.2 seconds is the time period of the one time period. Tau equal to 2.2 second. So when you charge, this is the voltage of the capacitor charging voltage, and this is the time axis. The capacitor will slowly charge like this. So for the capacitor to reach at one time constant 1 tau, it will charge to 63% of the applied voltage, maximum voltage. That's a 10 volt here. So here if you see, what is the option? Option A, 6.3 volt at 2.2 seconds. So that is the right answer. 63% of 10 volt is 6.3 volt. That will be in one time constant, the capacitor will charge up to 6.3 volt. So the answer is option A is the right answer. Okay, let's move to the question number 70. Question number 70. A digital panel meter measures a current of 0.2 amps through a resistor of 12.5 ohm. What is the minimum power rating required for the resistor? So power we have to what is the power dissipated in the resistor we have to find. P equal to I square R. What is the value of I? 0.2 square R 12.5 ohm. This is equal to 0.04 multiplied by 12.5. What do you get? 0.04 multiplied by. Now what I will do for simplifying the calculation, I can write it as 100 upon 4 divided by 100 multiplied by 125 upon 10. Correct? We have to do without calculator. So once you write like this, 4 into 125, that is 250, 500 you will get. 500 upon 1000, what do you get? 1 by 2 will get. So power is half watt. So minimum power rating required for the resistor is half watt. So because half watt power is getting dissipated in the resistor. Right guys? Yeah. Question number 71. The peak temperature in the reflow oven which uses tin 63% and lead 37% solder paste for soldering is typically, it is 230 degrees Celsius. Okay, 230 degrees Celsius. There is a oven is there. We'll apply the solder paste and place the components on the PCB and we'll put it in the oven for a particular time. It will get soldered and soldered. Which is not true for not true about laser. Option C, laser light is coherent and monochromatic and can be used to measure range. Collimated, I don't know the meaning of collimated. I was knowing, I forgot. 73. 4 carbon resistor color coded with yellow, violet, orange, silver. So it's a 4-band resistor. First is the digit 4. First two are digit. Third is the multiplier 10 to the power 3. fourth one is a percentage, plus or minus 10%. So it is 47 kilo ohms plus or minus 10%. So the answer is, what is the answer? 47 kilo, option A is the answer. 47 kilo ohms plus or minus 10% is the tolerance. Duty cycle. See, duty cycle, see, if you have a square wave or we have any waveform, see, single pulse will take. So this is the on time, this is the off time. So duty cycle equal to duty cycle of this waveform. Duty cycle equals T on time, okay, upon T on plus T off time. This is what the equation of duty cycle. So which is the answer? T on time upon on time plus off time. So option C is the right answer. Option C is the right answer. Question number 75. A buffer amplifier should have. Say buffer amplifier. A buffer amplifier, what is there? Buffer amplifier should drive a load, so low output impedance, and it should draw minimum current from the previous stage circuit. So high input impedance. So the answer is high input impedance, low output impedance. Answer is option A is the right answer. High input impedance, low output impedance. 1.250 milliwatt equals. If you want to write it in watt, what you will do? You have to divide it by 1000. Then we can write it in watt. So 0.012. No. We should have one more 0. Sorry. Let me write it again. So 1.250 milliwatt. If you want to write it in watt, what you have to do? You have to divide by 1000. So 0.001 1250 watt. What? If you want to convert to milliwatt, what you will do? If you multiply by 1000, what you will get? We will get 1.250. So the answer is right. Option B is the right answer. Which of the following is an instrument used to characterize optical fiber? Actually, I don't know the name, but panel meter is not used, multimeter also not used, impedance meter also not used. So it is option D, time domain reflectometer. Time domain reflectometer. A 12 volt battery has an internal resistance of 0.1 ohm. The maximum power that can be drawn from the battery is. So we have a battery. What is the 12 volt battery? And it has got internal resistance. What is the internal resistance? 0.1 ohm. See, this circuit is just like a Thevenin equivalent circuit. This is the VTH and this is the RTH. Maximum power. This is a maximum power transfer theorem. As per maximum power transfer theorem, what is P max? It equal to VTH square upon 4 times RTH. So VTH 12 square upon 4 times RT is the value of RTH 0.1. So which equal to 144 upon 0.4. 0.4, right? Now to simplify this, how do you simplify? I'll write it, I'll multiply both numerator and denominator by 10. 144 4. Now 144, if I divide, I'll get 144 divided by 4, 36. 1 0 is there. So it is 360 watt. 360 watt is the right answer. In an LR series circuit, L is 0.5 Henry and R is 250 ohm. What is the time constant? We have a circuit with a resistance and inductor. What is the time constant? That is also tau. I'll write it as tau equal to L upon R. What's the value of L here? 0.5 Henry. What is the value of R? It is 250. Now I will multiply both numerator and denominator by 10. So I'll get 5 upon 2500, right? Denominator and numerator I have multiplied by 5. So what it is? 1 upon 500 I'll get. So what is 1 upon 5? So this I can read. This is equal to, I'll write it here, 1 upon 5 multiplied by 1 upon 100. What is 1 upon 5? It's 0.2. 0.2, right? 0.2 multiplied by 0.01. So this is equal to, here, equal to 0.002. 0.002 is the answer. This is the last question. With that, we are completing the Vssc 2021 Technician B Electronics question paper. The class of an amplifier that operates with the least operation, all of you know it is class A. Class A means the amplifier will conduct for the entire circle. What is class B? It will conduct for only half of the circle, half of the input waveform. Class AB means more than 180 degree and less than 360 degree. I'm not going in details because we have spent a lot of time. It's almost 15 minutes video. So thanks for watching. If you like the video, please share with your friends.